Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is minimum penalty for a shop. So basically what you are given in the program statement is you are given a shop and customers are visiting for the shop at, at each hour, and the hours are indexed from 0 to n minus 1, where n is the customer size of the customer string that you will be given. Uh, Penalty for, let's say you have to close the shop at the earliest, so that you have to pay the least amount of the penalty, and the penalty is calculated as follows. If let's say you decide to close the shop at the jth hour, then for every hour when the shop is open, no customers come before this closing hour, you will increase the penalty by 1, and for every hour after this closing hour or on this closing hour, if you decide if some customers are coming to the shop and your shop is closed, then also you have to pay the penalty and it will be increased by 1. So what the program statement is asking you is you have to return the minimum possible penalty uh, you have to pay, and what is the minimum possible. Basically you have to return the minimum possible hour at which you can close your shop, so that you have to pay the minimum penalty. So let's take an example. What you will be given is you will be given a string customers, where each index in this string presents an hour. Let's say this is the given string y and y. Here y indicates that customers are coming, and indicates that no customer is coming. And let's mark the indices of this given string. These will be the hours in time when the shop is open. What you have to return is return minimum possible hour at which you can close your shop, so that you have to pay minimum penalty. So how this penalty will be calculated, it is also given to you. If let's say you decide to close your shop at the jth hour, then the uh, penalty will be number of, let me quickly change the color, number of customers visiting shop after it is being closed, plus number of hours when no customer visited, number of, it is also the number of hours when customers visited the shop after it is being closed. So and plus number of hours when no customer visited shop when it was open. It was open. So basically it will be the penalty will be the sum of number of hours when customers visited the shop after it being closed, and number of plus number of hours when no customer visited the shop when it was open. So basically what this means is, let's say you decide to close the shop at the jth hour. R here is nothing but the indices in customer string. Then what you will do is it will be number of occurrences of y on or after jth x, y is capital Y. So these are the number of customers who visited the shop after it have been closed, plus number of occurrences of n before jth index. These are the number of customers who visited, these are the number of hours. Basically, these are in terms of number of hours, number of hours. So number of hours when no customer visited the shop. This represents number of hours when no customer visited the shop when it was open. So let me write it also. Number of hours when no customer visited, when the shop was open. And this uh, is number of hours when customer visited, when shop was closed. Number of occurrences of y on or after jth index. Since you are closing your shop at the jth hour, so that's why we are taking considering the if there is a y on the jth position also, then we will also consider that. And number of occurrences of n before jth index. So it will be the number of hours when no customer visited when the shop was open. So this will be the penalty if I, let's say, decide to close the shop at the jth hour. Penalty for closing shop at jth hour. And for every hour you will calculate the penalty. Let me quickly change the color. For every hour you will calculate penalty and return minimum possible hour with minimum penalty. Return minimum hour with minimum penalty. This is the solution of the problem. Now let's have a look at the implementation of the solution. You may also want to see the constraints before moving towards before writing the solution. So since we are doing a single traversal of the customer string, so it will be linear time complexity and here or the length of the input is 10 raised to power 5 order. So it will be accepted. Why it will be accepted? Because the number of operations that your program will be requiring is 10 raised to power 5, order of 10 raised to power 5. And these are lesser than 10 raised to power 8 operations allowed in 1 second. Basically, if the number of operations your program requiring program also solution requires lesser than 10 raised to power 8 operations, then you will get a accepted solution. Or if this value number of operations of your solution reaches equal to or greater than this limit, then you may get a TLE, time limit exceeded. So that's not the case here. So we will get a accepted solution. And those of you who are new to this limit 10 raised to of 10 raised to power 8 operations, I will be providing a link of an article describing how the time complexity of accepted solution works varies according to input size. You can explore this article and then you will be able to understand why we are providing this limit. So, and for what input size, what time complexity solutions can be accepted. So let's have a look at the implementation part. What we are doing is we are checking the number of occurrences of n and y in the customer string. So, and then we are checking if the number of hours when no customer visited happens to be equal to 0. Since every hour a customer is visiting, you will be returning the what will be the minimum penalty possible. It will be 0, and it will be possible only when uh, you are at the size of the customer string. So all the visiting hours are over, and then number of visiting hours plus 1 will be, or you can say the number of visiting hours will be your answer, which is nothing but the size of the customer string. So this is that case when at every hour a customer is visiting the shop. So this is to cover that case, and these are nothing but the variables we will be using to calculate the penalty at each hour. So we will calculate the penalty at each hour. So pardon me if some spelling is incorrect. I hope it does not affect the understanding of your approach, the of your understanding of the approach of the solution. So this is we calculating the penalty at each hour. These are nothing but the hours. So at last we will be calculating if we are when we are done with the visiting hours. If there is a possibility, then that your minimum penalty will occur when all the visiting hours are over. This is to check whether the minimum penalty occurs after the visiting hours are over. At last, you will return the minimum shop closing time. So that's pretty much it. It was a kind of a greedy solution with linear time complexity, and the space complexity will be O of 1, since we are not using any extra space. The space used for these variables does not count. So that's pretty much it for the solution part and the approach. So if you are still having any doubts in the approach or the solution, then you may ask your doubts in the comment section. I will be more than happy to answer them. The code will be available in both of the languages, C++ and Java, in the GitHub repository. So thank you for watching. Thanks.